So truthfully, before you start playing this video, you should try and do these problems on your own and then come back and check them. There's no point in just writing down the answers once I do them for you. So try and do it on your own first. So you could pause it here and then go try and work some of the problems and come back and check how you did. And that way if you have questions, hopefully I'll be able to answer some of those. So I'm going to refer to this triangle at the right, and I'm going to write down the sign of the angle. Well, I always write this down as I'm working so I can refer to it. Okay, I know it's a right triangle, so I can apply right triangle trig here. Sine is the opposite over the hypotenuse, and this is the angle measure we're talking about. So the opposite side is 25, and the hypotenuse is 65. So we're going to write 25 over 65. Now that's good enough for now, okay? But that can be reduced, or you could even get a decimal for it. So 25 divided by 65, and we can write the decimal for it. 0.385, because I would round the 4 up to a 5. Looking for the cosine is the adjacent side. So adjacent means touching. So I'm looking at 60 over 65. Okay, and I will go ahead and do 60 divided by 65. And I get the decimal for that is 0.923 or 923 thousandths. And then for the tangent, I'm going to do the opposite side over the adjacent, which is 25 over 65. If you're having difficulty identifying which side is opposite, which side is adjacent, if we're talking about a triangle like the one that's here, oh wow, I did something wrong, didn't I? Yes, I did. It's 25 over 60, and I accidentally put 65 in there. That is not what I intended. That should be a 60 right there. I'm going to go back up here and fix that and make that be a 60. The reason I figured out I did something wrong was because all of a sudden I had the same decimal that was in the first one, and they should not be equivalent. So this should be 417 thousandths. Okay, but if you're having trouble, make sure you look at the triangle first, especially if we're only talking about one angle. This one might be a little bit more difficult, but if it's just one angle, I'd say, oh, that's opposite, that's adjacent, that's my hypotenuse. And then when I went to look at it further, I could figure that out. So here, I'm going to do the same thing, but it's going to pop around at the different angles on me here. So I've got to be really careful about which sides are for which triangles. If you want, draw yourself another triangle, exact same one, so that you can highlight the angle that they're talking about. So if this is E down here, that's 4.8. That's F with my right angle, that's 8 and 6.4, and that's D. So if I'm talking about angle D, 8 is my hypotenuse, 6.4 is my adjacent, and 4.8 is my opposite. But if I'm talking about angle E, 4.8 is my adjacent, and 6.4 is my opposite, and 8 would be my hypotenuse. So it all is dependent upon which angle you're referencing. So if I'm looking for the sine of D, this is the one that talks about angle D, and sine is opposite over hypotenuse. So I'm doing 4.8 over 8. And that gives me 0.6. Again, I'm talking about angle D, but this time cosine. So I want the adjacent over the hypotenuse. 6.4 over 8. So I do 6.4 divided by 8. And that gets me 0.8. When I do the sine of E, then I'm going to look at this triangle I drew here, because this is the reference angle now. And the sine is the opposite over the hypotenuse. So 6.4 over 8. And I've already done that calculation. That's 0.8. And the cosine of E is the adjacent over the hypotenuse. So 4.8 over 8. And I already did that calculation and got 0.6. The last two are talking about tangent. So the tangent of D is the opposite over the adjacent. So 4.8 over 6.4, which gets me 0.75. But this one is talking about angle E, so I'm going to this triangle and doing the opposite over the adjacent. 6.4 over 4.8. Remember, we talked about that in the first part of this, is that these two are reciprocals of each other. So I'm going to do 6.4 divided by 4.8, and that's going to get me 1.33. Repeating. All right, so now we have a couple more practice problems. We're just looking at the ratios. Here we have a diagram of a rocket. So sights the top of the rocket at 54 degrees. So that's angle of elevation, because here's the horizontal, and he looks up, okay, 54 degrees. He's standing 65 feet away. He's 5 foot tall, so they're saying that that part of the height of the rocket is already calculated at 5 feet. And we want to figure out the rest of the rocket. So remember, whatever we find out for x, we're going to have to add that 5 feet of the gentleman's height to it in order to get the final answer. So here is my angle measure. We're assuming this rocket is at a 90 degree with the ground, so we can use our right triangle trig. And from 54, this x looks like the opposite side, and this 65 is the adjacent side. So I'm writing SOHCAHTOA. And the only one that uses opposite and adjacent is the tangent. So I'm writing that the tangent of 54 degrees is equal to the opposite side, which is x, divided by the adjacent side, which is 65. And to solve this, I'm going to multiply both sides by 65. So the piece that I'm putting in my calculator is going to be 65 times the tangent of 54 degrees. Now that's going to get me x. It's not the height of the rocket because I still have to add that 5. So I'm doing 65 times the tangent of 54 degrees. And I'm looking at feet of 89.46. So that's what I'm putting in here is 89.46 plus the 5 feet. So that will get me a total of 94.46 feet is the height of the rocket. This one doesn't have a diagram, so it would be good for us to draw a diagram. So a straight water slide makes a 40-degree angle with the surface of the water. Okay, so we have the surface of the water here. We have a slide that comes down here into the water, and it says it makes a 40-degree angle. And let's say this is the ladder piece right here, which is at 90 degrees. It's on the sidewalk. It's not actually in the water. So with the surface of the water, the slide is 11.5 meters high. So that goes here, 11.5 meters high. It wants to know how long the actual slide is. So this is the piece that's missing. So compared to the 40 degrees, 11.5 is the opposite side, and x is the hypotenuse. So we need the ratio that uses opposite and hypotenuse. And that looks like it's going to be sine. So the sine of 40 degrees equals the opposite side divided by the hypotenuse. Now this is that situation with x in the denominator. Not much we can do about it. So we're just going to keep working it. So one of the things I suggested last time was the ability to reciprocate both sides. So I'm going to show that one this time. So if I reciprocate this side, it becomes 1 over the sine of 40 degrees. And if I reciprocate this side, it becomes x over 11.5. Well, that's actually pretty nice now because x is in the numerator where I want it. And to get rid of the 11.5 that's with it, it's division. So I could just multiply both sides by 11.5. So what I'm finding out now is that x will equal 11.5 divided by the sine of 40 degrees. So that's what I'm going to do. So 11.5 divided by the sine of 40 degrees, which gets me 17.89. So my answer will be 17.89, and we are dealing with meters. So I'll put that unit on there. Okay, so that was just another way of solving something if x automatically or just originally showed up in your denominator. Now what you will notice is all we've done so far is solve for missing sides. Okay, but we also have to be able to solve for missing angles, and that's what we're getting into in the next video.